Good luck.
Hello, it's me again. Did you miss me? What I'd like to do now is I'd like to do an application of the dot product. Now, thought to myself, yeah, we could just take some example from the textbook. We could do that. But in fact, I thought to myself, well, there was an interesting question on the 2010 Specialist Maths Exam 1. And I thought, well, let's have a look at that, just so you're kind of feeling a bit warm and fuzzy about what's in store for you at the end of the year. I happen to have the question right here. You guys, however, don't. So you'll need to get your tablets fired up, and you'll need to go to the Orientation Week website, to the Specialist Maths folder, and there should be a PDF file there called Exam 1 Question, or something like that, Exam 1 Vector Question. It's something like that. You'll find it. Okay, found it? Good. All right, well, let's get going then. Now, there's three parts of this question. We may as well look at all three parts, but the one I'm particularly interested in is, in fact, Part B. Part C is quite interesting as well, in fact. But however, Part A. They've given us a couple of points, point A and point B, relative to an origin. Here's our origin here. And our point A, let's see, they said it's 1, 2, 2. So it would be about here, I reckon. So there's our point A. 1, 2, 2. By the way, there's a vector, a position vector, OA, to the point A. We've got another point, the point B, negative, its coordinates -1, 3, 4. Oh yeah, it's probably, yeah, it's about here. There it is. Okay, and its coordinates are -1, 3, 4. We've got a vector, a position vector, that goes to that point. There we go, that's the position vector OB. Note the careful way that I've sketched this, the amount of time I've spent contemplating exactly where those points must go. Now, the first question, Part A. We've been asked to find an expression for the vector AB, and it's got to be in the form of an AI plus a BJ plus a CK. So, in other words, in the Cartesian form of a vector. Let's see now, the vector AB. That's going to be the vector AO plus the vector OB. That's going to be the negative of the vector OA plus the vector OB. Now, it'll probably be a good thing to have expressions for those two vectors, for the vector OA and for the vector OB. And we can get those expressions very easily, as follows. The vector OA is just going to be I plus 2j plus 2k, relative to the origin. We want the negative of it, so we'll have a negative. I plus 2j plus 2k. The vector OB, again, relative to our origin there, is just going to be minus I plus 3j plus 4k. So we've got our minus I plus 3j plus 4k. Now, all we have to do now is recall our simple arithmetic of vectors, which basically says that the components will add. So I've got a negative I here. In fact, let's expand it out just to really spell it out, make it so simple even a monkey could do it. 3j plus 4k. And that will be equal to minus I is minus 2i. We've got a minus 2j plus the 3j, and that will be plus a j. And we've got a 2k plus a 4k gives me a 6k. And that's all there is to it. 1 mark. Don't turn me off just there. Now, it's an easy mark, and in fact, looking at the assessor's report for that particular exam last year, I can actually see that 90% of the state got the right answer, got the 1 mark. So you couldn't get that mark. Anyway. Now, so we'll move on to Part B. Now, Part B is rather interesting. It asks us to basically show that the cosine of the angle between the vector OA and that vector AB is 490. So we actually know the answer we've got to get. So I'm just going to make a little bit of room here for us. Might just leave my careful picture up there. Now, we know that A dotted with B is equal to the magnitude A, magnitude B, cos of the angle between them. And we have been asked to show that the cosine of the angle between the vector OA and the vector AB, which I will draw in. Now the vector AB, there it is. There's our vector AB. We've been asked to show that the cosine of that angle is 4/9. Now, remember what I said in that first little lesson about the angle between the two vectors? The angle between these two vectors is not the angle up there, because these two vectors aren't joined tail to tail. That's not the angle between them. In fact, the angle between them, if we can imagine moving OA in such a way that its direction stayed the same and its size stayed the same, and we just sort of shifted it up a bit. We haven't changed the vector, but what I've done is I've moved it so it is now tail to tail with the vector AB. So in fact, that is the angle theta that the question is talking about. Okay? We don't need really to know that, but I wanted to point that out because it's a real trap that people can fall into. Now, we've been asked to find the cosine of the angle. Now we need to consider the vector OA dotted with the vector AB. Now, on the one hand, I know that it is going to be I plus 2j plus 2k dotted with my AB, which I'd worked out was minus 2i plus j plus 6k. Now, I'm going to do the old trick again. I only need i's dotting with i's and j's dotting with j's and k's dotting with k's, because I dot j's and I dot k's and j dot k's, they're all going to be 0. Think about it. Okay? So we're going to get, this dot product will give me a minus 2, this dot product will give me a plus 2, and this dot product will give me a plus 12. So altogether we get 12. So the dot product of these two vectors is 12 on the one hand. On the other hand, we know that it's also going to be the magnitude of the two vectors multiplied by the cosine of the angle between them. So the magnitude of the magnitude of vector OA is equal to, now what we do is we square the components. Now, so it's going to be 1 squared plus 2 squared plus 2 squared, and then we square root. So it'll be the square root of 1 squared plus 2 squared plus 2 squared. And I do believe that gives me the square root of 9, which is equal to 3. The magnitude of my vector AB, that's going to be the square root of. And again, we take the components and we square them. Now the square of negative 2 is going to give me 4. So I want negative 2 all squared, and that's going to be 4. I want 1 squared, which will be 1. And I want the 6 squared, which will be the 36. That's going to give me the square root of 4 plus 1 plus 36, which is the square root of 41. And I just realised I'll probably screwed this up, haven't I? We'll see. No, don't turn me off. It's good that they see this stuff up. They see this stuff up all the time in real life. We want to make this as real life as possible. So, let's double check this. 4 squared is 16, not 4.
No, it's minus 2 squared.
It's minus 2 squared, so that is 4. Let's cut and turn on in a moment. Okay, time flies, doesn't it? I found the mistake. And of course the mistake is the fact that up here, that ought to have been a negative 2 plus a 4, which should have given me a 2, not a 6. In which case we'll have a 2 here, not a 6. In which case we'll have a 4 here. And so, geez, this department's cheap, can't even afford good red pens anyway. We get 4. There we go. Now, I want you to notice something. Because my work was so beautifully set out, once I realised I'd made a mistake, I was able to go back to my earlier work, I was able to find the error easily, and I was able to fix it up easily. So in an exam, I might have lost about half a minute. Now if your work just looks like chicken vomit, you're just going to have to do it from scratch. Alright? So beautifully set out work makes it very easy to find any mistakes, to go back and fix them, and then move on. Okay, and we are going to move on because, of course, this is not a 6, it's a 4. So this will be a 16, and that'll be a 21, and we're still screwed. Turn me off for a moment. Notice? Now, if you're in this exam right now, you'd probably be sweating buckets, but luckily I'm in a nice air-conditioned room at the moment, cool as a cucumber. I go back, I check my beautiful work, I realise what the hell is that 4 squared doing there? It should be a 2 squared. 2 squared. 2 squared is 4. 9. And so we get 3. And I think, thank the Lord, we've got it. Alright. Now, so then, A dot B on the other hand, which hand was it? It was that hand. On the other hand, A dot B is going to be the magnitude of A times the magnitude of B times the cos of the angle between them. So, therefore, OA dotted with AB is also going to be 9 cos theta. Now this is a fantastic trick that we use all the time in maths, where you get two different expressions for exactly the same thing, which means that the two different expressions must actually equal each other. So, on the one hand, it was that one, we've got 4. On the other hand, we've got 9 cos theta. So therefore, we conclude that 4 is equal to 9 cos theta, and so cos theta is equal to 4/9, which was to be shown. QED for quite easily done, especially if you've got someone filming you and you can stop time and find your mistakes. We won't do part C right now.